Yes, friends, welcome back to Payment School. We're continuing with Algebra 1. That's the first topic. And today we're continuing with indices actually. And in our previous video, we talked about indices whereby we derived the rules or the laws or the properties we need to apply when handling numbers having indices. And today we are now going to see into examples. And just in case, if you're new to the channel, please support me by subscribing, like, comment, or you can even share. I'll be so grateful. So today we are going to continue with examples of that will help us see how we can apply the laws or the properties of indices we covered in our previous video. And the example for today, we start with these ones. So the first one we have 3 to the power 5 times 3 to the power 6 out of 3 to the power 4. Now remember, when you are multiplying same base but same indices of same base but different powers, and there is a multiplication, so 3 to the power 5 times 3 to the power 6 would just be 3. Then we add the powers out of 3 to the power 4. What would it imply? That means we would have up 3 to the power 11, 5 plus 6 out of 3 to the power 4. And still another property that we looked at, when you're dividing indices of same base, you simply replicate that base, then you subtract the power, which is 11 minus 4 would become what? 7. So your result would become 3 to the power 7. We looked at those properties in our previous videos. You can go back and check. The next one is going to be 18x squared y to the power 5 out of 3x to the power 4y. Now if you see, we need to know what like terms here. First of all, we have a constant here. We have 18 divided by 3. Let's first resolve that one. That's going to be 6, right? Okay. Then remain with x. So we have 6 times x squared out of x to the power 4 times y to the power 5 out of y. Okay. If we try to simplify that, we're going to have 6 up. Then x, remember, when we're the same base of x, then that means we're subtracting the powers, which means we're going to have x to the power 2 minus 4 would become negative 2. Is the power in the numerator minus power in the denominator. Then now we go for y. We're going to have y to the power 5 minus y to then minus 1, because same base of y but power 5 minus 1 we're dividing. So we have 4 there. What does it mean? We yet have another property. If you have, we looked at in the properties that if you have a number raised to a negative power, it's simply writing the reciprocal of that number with a positive power. So for that, in the same case, we're going to have 6 times 1 out of x squared for this x power negative 2 to be there, then times y to the power 4. So what does it imply? We're going to have 6y to the power 4 out of x squared. That's our final result. We go to the next one. We have 3x to the power 5 squared. First of all, we know that we first deal away with a constant. 3 squared will be 9. Okay, that's 3 squared, because we're going to have here 3 squared, then x to the power 5 squared if you give the square to each component inside that bracket. So we have 9, which is 3 squared. Now we have x to the power 5. Remember, we had, if you have a base, let me write up here. If you have a base, let me say a raised to another power, then raised to another power, we looked at that property that it will become that same base, but you multiply the powers to get the result. This is just saying that will be 8 to the power 10 for that case. So the same thing we're going to apply here. We have x to the power 5 raised to another power 2. Okay, it's like x to the power 5 raised to another power 2. It's going to result to 9x to the power 5 times 2, which will become 9x to the power 10. So that's what we have there. So that's the result. Now we go to the next one. Let's write the following in expressions in index form. Number 2, write in index form. Okay, Now let's say that our first number, let me say A, is 2 out of x3, B is 1 out of 2x to power 4, then C is x to power 4 to power half. Okay, so now we can see that now we first of all we have numbers. We don't touch numbers, we just deal with these parameters, the x. So let's check our solution. A will actually be 2 out of x cubed will actually be 2. Remember that if we take x up, now if we take x up, imagine we have 2 out of x cubed. There is a silent x here to a power 0. So applying the rule of the same base, you subtract denominators, we're going to have x going up, then 0 minus 3 will become what? A negative 3. So we're going to have x power negative 3 if you take that out. So we are going to end up with that. That is that in index form. Then B, we're going to apply the same thing. You have half. Now to take, remember we have a silent x to power 0 here, then a x to power 4 down here for this number. Okay, so that we know that. We also, in our previous video, we looked at how a number curve becomes x to power 0, a number x to power 0 becomes 1. You can go back and check if you want to know more when you're deriving the properties. So we already have these things and we're just applying them. So we have a half. X is now up to power 0 minus 4. What does it mean? We're going to remain in the half of x to power negative 4, because 0 minus 4 is negative 4. Okay, now we go to the next one, which is C. That's x to power 4 to power half. I told you if you have a base raised to another power, then again to and raised to another power, it's just simply multiplying the power. And you know 4 divided by 2 will remain 2, so we're going to have x to power 2. So we have simplified that. Let's go to the next set of numbers. Okay, I think let's add another one. Let me say D. I want something a bit more complex just to cover under that. For x cubed, no, let's say to power 4 out of 2x, all under that root. Okay, and we check it out here. Let's say we have D. Let's try to check that. Cube root of 54 x to power 4 out of 2x. Okay, so if I simplify the thing under the root, 54 divided by 2 first of all is 27, right? Okay, for that. Then x, we have x to power 4 minus 1, because same base, we subtract the power, so 4 minus 1 becomes 3. So that's what we have. What else? Now we know 27 in terms of 3. This is the cube root. Remember the factors of 27. There's 1 times 27, that one you don't need, it doesn't change anything. There's another one, 3 times 9 gives us that, so you have 3 times 9, and into 9 there's another 2 sets of 3, so you have 3 times 3 times 3 to give us 27. So what does it mean? Is 3 cubed. So we're going to have cube root of 3 cubed x cubed. Okay, that's the same as saying cube root of 3x all raised to power 3. Okay, and how can we the property we looked at is that if you have the cube root can also be expressed as cube root. We have inside the bracket, we have the root, the cube root, we have 3x to power 3. But in our previous, we remember that we realized that a to the power 1 out of 3 is the same as a cube root. When cube root of a, when we looked at in our previous video. So that means that all of that cube root we are going to replace with 1 out of 3, right? I think we can get that from that. Now this multiplying themselves, we have 3x to the power 3 times 1 out of 3. We already know that property, we have been doing it over and over again. So we are going to have now 3 divided by 3 will become 1, so that we remain with only 3x. Okay, I think you can observe a transition from here up to here. That's a very good property that we had to put in. Let us go to the next set of questions. Let me flip the page over. I can write the question here, then I flip the page later. The question is saying, without using a calculator, let's evaluate. Let me say no calculator. Evaluate a 9 to the power negative 3 out of 2. Okay, then let me say b is saying 1 and 11 out of 25. 1 and 11 out of 25 to the power negative half. Okay, let's try to deal with that. Let's try to, no using calculator, no pressing any calculator, so we try to solve this. Let's start with a as a solution. Okay, a is saying 9 to the power negative 3 out of 2. Okay, now you first have to remember we have a negative power. A to a negative power, let me say 2, is going to be 1 out of a to the positive of that power. So the same thing, we have 9 to the negative power is going to be 1 out of 9 to the positive of that power. That property, we are well acquainted with it. Okay, so now what else do? We try to simplify that, and you know that this is the same as having 1 out of 9 to the power 3, okay, times half. Is it okay? Or which could also be the same as having 1 to the power 9 to the power half times 3. Okay, like that. Think we can get that? So what does it mean actually here? We can actually put 1 to the power 9 to the power half first, then we put to the cube. We know that property. So in the bracket first, square root of 9 is 3. Then we consider this now to the power 3. So literally we have 1 out of 3 to the power 3 is what? 27. I guess that. So we have 27. 3 times 3 times 3 is 27. So we have simplified that without using a calculator, just applying our properties of indices. So let's check the second question. What was it saying? It was saying that 1 and 11 out of 25. So we have 1 and 11 out of 25, then raised to a power of negative half there. Okay, so what do we do here? Still applying that, raised to a negative power, put 1 up, then put the rest down, then raised to a positive power. We derived such a property in our previous video. Go back and check, please, and don't forget to like and subscribe and share. Then now we can, this is a mixed fraction. We change it to an improper fraction since it's mixed. So we're going to have 1 out of, now to change this to an improper fraction, we're going to have that, we multiply by that, then add that on top. So 25 times 1, 25 plus 11 becomes 36, I think. 36 out of 25, all to power half. Okay, it's the same as having 1 out of 36 to its own power, then 25 to its own power. Okay, so what do we have? We're going back here, we have 1 out of, now remember we have 1, we're dividing by another power, which is a fraction there. We have that, so we can, when we want to multiply, we can just get the reciprocal of that, power half also. I think we can know that how we went to that. Now we are going to have, what else are we going to do here? 1 times 25 to power half. Remember we said any number raised to power half is the same as square root of that number. So square root of 25 will actually be, okay, let me write that. I never wanted to write it. No, this is the same as square root of 36 also. Remember, square root can also, you can ignore this for the case of square root. You can just put root 25, and it's always known to be the square root of 25. So we have 1 times root of 25. Square root of 25 is 5. Square root of 36 is 6. So we have 5 out of 6 as a result. And now we go and check the last part of our question, the last bunch of the question. We have find the value of x when you're given the following. Let's just say find x. Okay, let's say a is saying 5 to the power x equals to 1, 2, 5. Then b is saying x to the power 2 out of 3 equals to 4. Let's try to solve for x in these two equations. We flip over, we have space 5 to the power x equals to 125. We start with that. Solution, you have 5 to the power x equals to 125. Okay, now we need to look for how many times can that means actually we can see 20. We can try to check how many 25s are here by dividing 25 by 5 over and over again to see how many 5s can be inside 125. 125, if you divide by 5, what do you have? I think it can be 25. Okay, then if you divide by 5 again, it can be 5. So you find you have 3 5s there. Or the simple way, you can first raise 5 to power 1, you get 5. Raise another one, 5 to power 2, you have 5 times 5. Okay, then 5 to power 3, you will have 5 times 5 times 5. You check, this is just 5, you know, this 25, you know, then this one gives you 125. So you can actually replace 125 with 5 to power 3. So you have 5 to power x equals to 5 to power 3. Okay, same base this side. But that, what does it imply? And there is an equal sign saying these two are equal. If the base are equal, that implies that their powers or their indices are the same. So that implies that actually x equals to 3. Another thing would be taking this 5 the other side. No, that would not work so much. So we just compare. It's all about comparing now. I thought it was going to be a division kind of thing. So we have that given by that. We can now go ahead and try to check. Another thing I wanted to know was actually if you divide throughout by 5 out of 3, you would have there 5 by x divided by 5 to power 3 equals to 1. Then you have 5 to power x minus 3 giving you 1, which it would be hard for you to, you know, that 1 would be 5 to power 0. You replace 1 with 5 to power 0, then you compare it, still you have 5x minus 3 equals to 5 to power 0, and this would be x minus 3 equals to 0, which is a longer way to reach there. So we just do that. So now let's go to the second one, which is, this was A, then B. We're going to have x to the power 2 out of 3 giving you 4. Okay, so we now have here x to the power 3. You know, first of all, is x to the power 2 out of 3 is the same as having 2 times 1 out of 3. Okay, giving us 4. What can we see from here? Is like saying that we have x to power, okay, x to the power third, then we square it. I'm trying to bring the square out. Then here we know 4 can be, if you divide by 2, you have another 2. So we have 2 squared here. 2 times 2 giving you 4, which gives you 2 squared. So actually we can see that if we take square root on both sides, what would we have? If we take square root on both sides, taking square roots on both sides, okay, what would we have? We're going to have x to the power third, okay, giving us 2. That means I say x to the power third squared equals to 2 squared, take square root. You remember that equals to that. For this case, we are not good. But remember that every time we have a square root, we need to consider a plus or a minus for our result. Why? Because if you square positive 2, you're going to have 4. Likewise, if you square negative 2, you're still going to have 4. That's why we consider both cases. So for the first case, we're going to have our x will actually now be, if you try to take a cube root to remove this one, imagine now we raise the both sides to power 3. What would we have? We need to have x to power third, then we take to power 3 equals to plus or minus 2 to power 3. So how would we find our x? Our x would actually be, you see this one would cancel one, because that it's the same as saying that we looked at that before, which is the same as x, because this 3 would cancel out, remain with only x. So we have x this side giving us plus 2 cubed or minus 2 cubed. What would be our result? X would be either be positive 8 or negative 8. Why? Because negative 2 times negative 2 times negative 2, this will be negative 4 times, positive 4 times negative 2, which will end up to be negative 8. So for this case, we have our x positive 8 or negative 8. What does it mean? Therefore, x would be plus or minus 8. So that's done for today. Please thank you for coming, and I would like to see you again in my next video, and please support me. Don't forget to subscribe, like, share, comment. See you in my next video.